E5 aluminium. Same setup as each time: properties, acquisition, design consideration, and application. Aluminium is a material which we like a lot in facades, so we will see some more facade samples in here. It's actually a material similar to steel, quite good in compressive and tensile strength. Still a ductile behavior, which we see here. Not fire, not burnable. Doesn't burn as material, which makes it nice as well. But it's not that strength, not having that strength as steel, which makes it interesting for the manufacturing of facades, because we want to have very specific shapes of our geometry, but the forces are not that much an aspect as, for example, large infrastructures, bridges, and things like this. Which brings us to this slide: compressive strength, tensile strength, Young's module, thermal conductivity. Thermal conductivity, close to the one of steel, not that good in transporting energy, perfect. Good in transporting energy, but still transporting energy quite well, which leads us to the situation that we need to at some point have a thermal break between the inner and the outer layer. We will see that later in this system. It's a very common material on use on our planet. We use it a lot. It's a production process which is not that nice, but recycling is an opportunity which is involving a lot. So we see a lot of aluminium nowadays not only being harvested by on the planet itself, but also being harvested on existing structures, then being recycled for new structures. The material, the bauxite, is harvested, then crunched, then brought into a first production process, which ends up in an aluminium oxide, and then brought in a second production process, which brings it to a pure aluminium. And this pure aluminium then is by electricity boiled 950 degrees, as it is said here, to end up into liquid aluminium, which is then casted into dies, which are the blocks which we use for our aluminium manufacturing process, which is the following up process. This is done at the plants where the manufacturing the aluminium is harvested, and then these blocks are transported, shipped to the places where the aluminium profiles are made, and then these are the blocks as we know them. Then these blocks are brought again into an electrical process to make them liquid, which is this one. It's actually dies 6 meters deep, where the aluminium is brought into and then boiled with electricity brought to temperature and then boiled to create these blocks, 3 to 6 meter long blocks, diameter 30 centimeters, something like this, which is exactly the dimension which we need to then push them through dies, which is the next process. As said, aluminium by its material properties allows us to follow an extrusion process. This is an extrusion die, so we have that aluminium bar being brought in front of this extrusion die and then pushed through the extrusion die, and by that creates the outer shape, which is what we see there, and this outer shape, and it needs to create these inner openings. So this is actually the negative shape of the inner opening to allow a certain geometry, a certain dimension. Sometimes this goes wrong. Let's say this smart picture where you see that the aluminium in the extrusion process, for whatever reason, it stopped the process and then the aluminium is stuck in the die. And you can imagine this die doesn't work. You have to rebuild the die. This is the extrusion machine itself. We see here, this is the pusher, which then pushes the bar through the extrusion profile. This is the entire process. So the die is brought somewhere here, then the bar is brought in here, and then this process pushes the bar through the extrusion die as a result. And this is what the results are when they're finished. So we see the outer shape, we see the inner shape, and we can imagine that this extrusion die needs to secure that the aluminium is able to be shaped at the outside and be shaped at the inside. To do that, to be shaped at the inside, the inner bar, the inner component of the die needs to be held in position, and the aluminium has to flow around these arms which keep them in position to then create this shape. You also can identify that, say, very nice geometries, very sharp geometries are possible to be made, and that's where aluminium is interesting for the facade industry, because you can create these super sharp and sharp-edged components. Left picture shows a result of a problem in the extrusion process. I quite just like it as design. It's not wanted. It's a result which then is recycled. A next step. Next level of dealing with the aluminium, it's the corrosion process. The aluminium surface happens very fastly. It doesn't continue deeper, the corrosion, which means that we either keep the aluminium as a raw material with then the corroded surface, which is this nice shiny aluminium, silver aluminium-like surface, which is the one way to use it. Next way is coating it with a paint. And this is a typical coating plant. So the aluminium profiles are taken, lifted, and then brought into this coating device. Then they're dried and then brought into the following up manufacturing process, or alternatively with an anodic coating, which is an acid where they're brought into. Then the surface corrodes in a different way depending on the acid, and then the surface is the final surface as we use it in our facade systems. Then it goes to stock and then it's used when we need it. Applications for aluminium, as I said, these super nice sharp profiles. If they're expected to be a window, we see a corner cleat connection happening here. Then yeah, they're cut at in a 45-degree angle and then brought together. The profiles which we use are these. So this is one aluminium provider. There are several which are having all the different profiles, and what we nicely see is they have all these sharp edges with the screw channel and the channels to take the rubbers for the sealant, and some additional screws to be brought into. Also, the additional strength is brought into position to make the profiles, if they are larger, deeper, capable for the structural loads being used. You can imagine each of these profiles needs an individual die, with then obviously the costs related to the die. A different setup, a different functionality. This is a glass spider connecting device, which again shows very sharp profiles which are to be used. Or this one as an rail system at the back of an outer cladding system, whatever cladding is expected, or maybe even as a cladding. These are aluminium sheets, two very thin layers of aluminium sheet with a polyurethane core, 5 millimeter polyurethane core, with the consequence that we have a sheet metal with an aluminium surface, a coated or pure aluminium surface, and then being still a sandwich-like structure, being able to go to a certain dimension for its functionality. This is a cladding done in this aluminium polyurethane core sandwich components, as just described. If you want to continue with the manufacturing, this is an aluminium profile of a Windows system. Allow me to stay here for a minute. As I said, thermal conductivity is quite good for aluminium, so the energy transport works well. So we need to have a thermal break from the outer surface to the inner surface to reduce this thermal conductivity, reduce the energy transport. And to do so, we create this additional thermal break. You see the mouse thermal break, which happens here, which is a plastic component being integrated into these two aluminium extruded aluminium profiles, or an extruded plastic profile being added to the extruded aluminium profile, brought in together, having these sharp edges, which are then clamping them and keeping them in position, and then by that being a thermal break within this system. We see manufacturing happening here. So first assembly happening, then the cutting and dimension automized as a system, then all the drilling which is necessary in these processes to secure the right geometry and proper performance as a system, and then the whole thing is brought together at this as a prefab component, which is then brought on site as an aluminium profile. This is about aluminium and the people being involved, shown here, and by that I stop.